Okay, so if you remember this chart we filled out last class period, we got these different answers, okay? And I want to point out to you two things. I want to point out to you that when we multiply by -2, our inequality that results becomes false. When we divide by -2, our inequality that results becomes false as well. So these two appear to be the only time things are different. Okay, so adding or subtracting are the same. Okay. Multiplying and dividing are the same as well. I don't know what that is. If it's positive. Okay. Where it's different is if it's negative. It has to be a negative number. Okay, so what I want to do is I want to show you some examples. So basically, we're doing this. Oh, sorry. I want that to be 20. Okay. So remember, with an equal sign, we would subtract 5 from both sides. So I'm going to do the same thing here. I'm going to draw this line. So 3x, instead of an equal sign, I'm going to write down the less than or equal to. I'm going to divide by 3. Look, I solved that one the same exact way. Okay. Now, so what this means that any number less than or equal to 5, so a number like 2, would work. So if I go back up here and I plug in 2, okay, 3 times 2 plus 5 is less than or equal to 20. Well, this is 6 plus 5 is less than or equal to 20, and 11 is less than or equal to 20. Yes, that works, okay? So what this is doing is this is showing us the answer is every number less than or equal to 5. So I can plug in any number equal to 5 or smaller than 5 and it will work. What would happen if I had this? Let's look at it. Okay, it's the same question except now it's a -3x. So I'm going to subtract 5. Oh yeah, and I changed the inequality. Okay, so I draw my line through the inequality. -3x. Remember, I'm putting the inequality, and it's equal to 15. So watch what happens. I'm going to divide both sides by -3. You remember back here when I divided by a -2, it switched. It wasn't true. Well, let's see if this is going to be x. Let's say I keep the same inequality, and this time I get -5. 15 divided by -3. So what this answer is telling me is any number bigger than or equal to -5 should make this inequality true. So let's pick 0, because I want to pick an easy number to work with. Okay, so here's the original. -3 times 0, this is what I plugged in, plus 5. So this is 0. So what I get is 5 is greater than or equal to 20. That's false. Okay. So how do I keep it true? if I want this inequality to make the solution correct, here's what I need to do. I need to switch the inequality. I need to change the direction. Okay, I need to change the direction of the inequality. If I do that, now what it's telling me is I'm going to take, let's see what happens here. Okay, I'm going to clean this up a little bit. So now the answer is telling me that I need to take any number smaller than or equal to -5. So something smaller than -5 is -10. So I'm going to plug in -10 into the original inequality. Okay, notice that it's the original. This was the original problem. Okay, so -3 times -10 is 30, plus 5 is greater than or equal to 20. This is 35. Okay, so you see it works. This is true because of the fact that I flipped the inequality, and here's why. Because I'm dividing both sides by a -3. Remember, it only happens with multiplication or division of a negative number. If I'm adding or subtracting, it doesn't matter. If I'm multiplying or dividing by a positive, it doesn't matter. Remember here, I didn't do anything different. It's whenever I got to this problem. You'll notice that the -3 is dealing with the x. That's when we flip the inequality. Okay, let me show you something that a lot of people think they're supposed to flip. Okay, so let's say I got this. 2x minus 7 is greater than, let's do -3. No, let's do +3. No, we want to do, let's make this a plus. Yeah, -3. Okay, so here's the inequality. I draw my line down through the center. I'm going to subtract 3 from both sides. Oh, sorry, subtract 7 from both sides. I said 3, but I wrote 7. Okay, so that's going to give me 2x greater than -10. Okay, -3 minus 7, -10. So now I'm going to divide both sides by 2. Okay, x, this is going to be -5. Does the inequality flip? Look at this number. Is it negative? No, it's not. So we don't flip. Okay? Just because this number's negative, that's not the one that matters. It's the one that we're dividing by. We're dividing both sides by 2. Okay? So those are a couple examples. I'm going to go through the process and kind of do some more just to show you. But otherwise, the principle is the same. Okay? When we multiply or divide by a negative number, that's when we are going to experience something that's slightly different than if it were an equal sign. An equal sign we can't flip, but an inequality we can. So I'll be back to work out a few more questions so that you can watch. Okay, so I'm going to get the s by itself. Subtract 8. S is less than 2. Get d by itself. Add 3. D is greater than or equal to -8. Now they're also going to ask you to graph these. So what we're going to do is we're going to draw a number line. I'm going to put this in the middle, and then I'm going to put a few numbers on either side. Okay, so I'm going to put -8 in the middle, -7, -6, -5. negative 10, negative 11. Right. Now, we want to represent all of the numbers smaller than 2. Okay. So we know that all the answers are down here. Does it include 2? No. So what we're going to do is we're going to write an open circle. The open circle says it doesn't include the number. And remember, our answers are all of these numbers. So what we're going to do is we're going to shade this part. Notice I shaded the arrow too, because it's everything. Everything down here is an answer to this question. Okay, so I put an open circle on 2 because it doesn't include the number 2. And then I shaded everything smaller. So if I read this left to right, S is less than 2. Remember, we need the letter on the left. So the letter represents all of the answers. It's less than 2, so smaller than 2. So I shaded it this way. Okay. Now, if you notice, this one doesn't include negative 8. Yes, it does. So what I'm going to do is I'm going to fill in that circle. Okay, so this is called a closed circle. Says it does include the number. Okay, so it's a closed circle. It's filled in because it's got that little bar underneath which says D is greater than or equal to negative 8. Now, this one is D is bigger than negative 8. So where are the values bigger? Over this way. So I'm going to shade right. Notice once again I'm going to shade the arrow because I want it to include all of the numbers that go past my drawing. Okay. Okay. Alright, so we're going to move the 10x. The reason why I'm moving in the 10x is because the numbers are already on the right. Okay, so negative 6x is greater than negative 18. I need to get rid of the negative 6, so I'm going to divide both sides by negative 6. And I get x, I get 3. You recognize, look at the number that I divided by. It's a negative. Remember the chart. The chart tells me that if I divide by a negative and I use the same inequality, it's not going to be true. So I flip the inequality. Okay, flip it because you divided by a negative 6. Okay. I can quickly tell whether that works by picking a number that's smaller than 3 and plugging it in. Okay, so then we graph it. 3, 4, 5. 2, 1. Okay, this is less than. Is it going to be an open circle, or am I going to draw in the circle that's filled? Remember, the open circle says it does not include the number 3. The filled in circle says it does. So for this one, I'm going to do an open circle. And it says it's smaller than 3, so that's everything down this way. So that is the drawing of everything that works. Okay, so what you're going to do for the rest of class is you're going to practice some more of these, right? Use these notes, whatever you need to do, practice them, write it down as I go through it, look over it. Hopefully you're good to go, all right? So even though I'm in Utai Thani, you can still learn. All right, thanks. See you.